In today's video, we're going to look at sections 3.1 and 3.2, which will be examining relationships and also looking at what a correlation coefficient is. So first of all, let's look at two variables that we'll be discussing. And first of all, we have an explanatory variable, which was also called our independent variable in previous classes. And basically, it's the variable that we would graph on the horizontal axis, and it's the variable that is the one that's trying to explain why the changes are taking place. Quite often it's time. Um, for instance, if we were looking at what was going to happen if we were measuring the temperature of a cup of water as it was cooling on a table. And so maybe time would be on our horizontal axis and the temperature would be the response variable. And as time moved on independently, then our response variable would dependently change relative to that time. So explanatory variable we've previously called an independent variable, and our response variable is our dependent variable. And sometimes when we look at some data, it's really hard to determine which one is independent and dependent, but quite often we can tell which one is affecting the other one. So if we look at this example number 1, how well does a child's height at age 6 predict his height at age 16? To find out, we'd measure the heights of a large group of children at age 6 and then wait until they reach age 16, and then we'd measure their height again. Now, we would have two variables that we'd be looking at. We'd be looking at, for a specific child, we'd look at its 6-year-old height and then also its corresponding 16-year-old height. Now, this is different from the previous chapters that we've looked at. In the previous chapters, we had one variable statistics. Now we're looking at two variable statistics. Each child would have two pieces of data, that one being at the height at 6 years old and one being the height at 16 years old. And we can see that our explanatory variable, as opposed to our response variable, in this case, we definitely would have the height of the child at 6 being the variable that would be explaining what the height would be at age 16. We wouldn't anticipate looking at 16 and then retroactively going back and predicting what the child's height was at 6. So we would think possibly there might be a positive association, we'll be using those terms, that maybe if we have children who are taller at 6, maybe that will be the taller 16-year-old. But in any case, explanatory versus response. Now, we also have the idea of whether a variable is categorical or quantitative. Now, in this case, we would be measuring the height of each child, so we would have a quantitative value for not only the explanatory variable, but also the response variable. Here's an example similar where we have a couple pieces of information that we're going to get from a single subject, but you'll see the difference in the variable idea here. There may be a gender gap in political party preference in the U.S., with women more likely than men to prefer Democratic candidates. A political scientist selects a large group of registered voters, both men and women. She asks each voter whether they vote for the Democrat or for the Republican candidate in the last congressional election. What are the explanatory and response variables? Now, notice that the gender of the person was the explanatory variable. We're trying to find out, do men or women have a different preference in political parties? So we'd be looking at the gender of the person initially, and then the response variable that the person would be giving would be whether the preference was to have a Democratic or Republican candidate for that seat in the congressional election. Now, in this case, both of these are categorical. There's no number associated with the gender or with the political party. Now, when we look at data, if it's categorical versus categorical, we have to study the data and interpret the data and use different statistical techniques on this type of categorical to categorical combination, as opposed to if we have numerical to numerical or quantitative to quantitative. And we'll be looking at this type of comparison in later chapters. the quantitative to quantitative using two variable statistics is what we'll be looking at in this chapter and in the next chapter. Now, you can read through this idea on number 5, but let's just turn the page and see that we had some data here, and we have the year, and we have the number of boats registered. We have the number of accidents that were taking place and the number of fatalities. And if we want to examine the relationship between the number of jet skis in use and the number of accidents, which would be the explanatory variable, and we can see that the number of jet skis in use would explain or be the one that would control how many accidents. We wouldn't look at how many accidents there were and retroactively say, oh, there must be this many jet skis. So our number of jet skis would be our explanatory variable, and the number of accidents would be our response variable. Now, in AP Statistics and on the exam, as well as on my exams, we'll have to make different scatter plots. Make sure on a scatter plot that you look at the data that is going to be placed down on your axes. And in this case, I want the number of jet skis in use, which I'm labeling on my horizontal axis, which is my explanatory variable. And I'm making sure that I have enough space to include the data. I don't want to go chop. There's and skip portions of the graph. I want the whole number line to be shown. I don't have the axis all kind of jumbled and garbled with all kinds of labeling down here, like 10,000, 20,000, 30,000, and so on. I put some tick marks that don't actually have some numerical values underneath them, and it helps me. I can see that this is the $100,000 mark, or 100,000 number of jet skis in use mark, but make sure that this is all going in the appropriate scaling. Now, also notice that the number of accidents I have clearly labeled on my vertical axis, which is my response variable, and I have this going up to at least 4,000 because I had 4,028 as my highest number of accidents up above, and I don't have to have my y-axis scaled the same as my x-axis, but make sure you're labeling your axes appropriately. Now, I didn't connect the dot on these. This is just a scatter plot. I don't have all the data in between. I don't know what happens between this number of jet skis in use and this number of jet skis in use, so I didn't necessarily connect the dots on these. But when I look at this, I can see some trend that it does appear as though the number of jet skis in use, as that increases, it looks like the number of accidents also increases, and it looks pretty linear. So if we're looking at some type of a scatter plot, we would want to look at the direction of the association. Do we have as the number of jet skis in use goes up, do the number of accidents increase? And we can see that that is happening. Does it form? Does it seem to form a line? Does it seem to form some type of a curve? Does it seem to flatten out? Does it have really no pattern? And then we would look at strength. Now, strength being, does the pattern or the form that you're speaking on, say in this case, I say this is quite linear, how well does that data seem to fit that type of a linear pattern? And so that would describe the strength. Now, we also like to note if we see a big cluster of data. So, for instance, let's say that there were a lot of different times, not in this case, but let's say if we had the graph of the data differently. Let's say there were a lot of 200,000 approximate number of jet skis in use with accidents. And if there had been some big cluster, that might be something that we might want to discuss if we're interpreting the data. And then another thing we would like to look at is whether we have a positive association between our data or a negative association, or possibly no association. And our positive association would be as our explanatory variable increases, does our number of accidents increase? Or if it's a negative association, as our number of jet skis increases, that would have our number of accidents decrease. Okay, so that would be a negative association, where as one variable gets bigger, the other variable gets smaller. Now let's look at the next section. And the next section is going to look at the correlation coefficient. And the correlation coefficient, truthfully, you did work with in algebra. However, you used the magic of your calculator to describe this. And we'll find that correlation, if you'll remember, is for you, you saw a little letter R. And this little letter R was describing two things. It was describing not only the strength of the association that you have, that is a linear pattern, but it also describes what the direction of the association is. And if you remember, when you used your calculator, and that was all you did previously,